Welcome to this explainer. Today, we're going to explore a really fantastic mathematical concept, mastering simultaneous linear equations, including their methods and real-world applications. Now, I've always liked to think of math not just as, numbers sitting passively on a page, but as building a brilliant, actionable toolkit to solve real-world mysteries. Because when you have multiple pieces of unknown information, you absolutely need a structured way to uncover the truth. And that is exactly what we're going to build together today.
Okay, let's dive right into this. How do you find the exact prices of two different products when you only have their combined totals? Imagine you're managing business finances, or maybe determining age relationships, or calculating motion and speed. You often have two unknown quantities, but you only know how they interact with each other. This is a very real, high-stakes puzzle, and to solve it, we need a highly specific mathematical framework.
So here's our game plan for this explainer. First, two unknowns, one solution. Then, the elimination method, followed by the substitution method and graphical intersections. Finally, we'll tackle the boss levels of fractions and word problems, and we'll wrap the whole thing up with exam tips and pitfalls.
All right, kicking things off with Section 1, two unknowns, one solution, or as I like to call it, the mystery of variables.
Okay, so what exactly are simultaneous linear equations? Basically, they're a pair of linear equations involving the exact same variables that must be satisfied at the exact same time. The absolute keyword here is simultaneously. Take a really simple example from our source data. X plus y equals 8 and x minus y equals 2. You can't just pick any random numbers that add up to 8. The values of x and y that you choose absolutely have to work for the second equation as well. They are completely locked together.
Moving right along to Section 2, the elimination method. This is our tool number 1. The eliminator.
I want you to think of elimination as the heavy hammer in your toolkit, used to completely destroy a variable. Let's walk through our first example. For step 1, we simply add the two equations together vertically. If we add x plus y equals 8 to x minus y equals 2, just watch what happens. The positive y and the negative y perfectly cancel each other out. They're eliminated. We're left with 2x equals 10, which easily gives us x equals 5. For step 2, we just take that 5 and substitute it right back into our first equation. So 5 plus y equals 8, which means y must be 3. Our perfect simultaneous solution is 5, 3.
But hey, addition isn't our only option here. In our second example, adding actually won't help us eliminate a variable, but subtracting works just as well. We have 2x plus 3y equals 13 and 2x minus y equals 1. If we subtract the entire second equation from the first one, the 2x perfectly cancels out the 2x. Just be super careful with your signs here. 3y minus negative y becomes 4y. 13 minus 1 is 12. So we get 4y equals 12, leaving us with y equals 3. We then substitute that 3 back into the second equation, giving us 2x minus 3 equals 1, and we easily find that x equals 2. The solution is 2, 3.
All right, Section 3, the substitution method. This is tool number 2, the surgical swap.
So, if elimination is our heavy hammer, substitution is a much more precise, surgical maneuver where we cleanly swap a variable out. Watch how this method brilliantly bypasses tricky coefficients by inserting one equation entirely inside the other. Looking at step 1, we take x plus y equals 7 and rearrange it so y is all by itself. It becomes y equals 7 minus x. Then step 2 is where we do the surgical swap. We take that 7 minus x and plug it exactly where the y is in our second equation. So 2x minus y equals 5 becomes 2x minus, in parentheses, 7 minus x equals 5. When we expand that out and solve it, we find x equals 4. Finally, for step 3, we substitute x equals 4 back into our rearranged equation, y equals 7 minus 4, giving us y equals 3. Our final solution, 4, 3. It's just brilliant and clean.
Up next, Section 4, graphical intersections and outcomes. Let's look at tool number 3, the blueprint.
Sometimes we really need to shift from abstract algebra to visual proof, because these equations aren't just random floating numbers, they're actually straight lines on a map. The absolute core concept here is that the solution is the exact point where two straight lines intersect on a coordinate plane.
For instance, if you graphed the equation y equals x plus 1 and the equation y equals negative x plus 5, you'd end up drawing two distinct straight lines. That single, unique point where those two lines cross at the coordinates 2, 3 is the exact visual equivalent of our mathematical answers.
Now, there are actually three possible outcomes when you graph these lines. Case 1, intersecting lines. They cross once, giving us exactly one unique solution. Case 2, parallel lines. These guys run side by side forever. It's honestly a bit of a mathematical tragedy. They will never ever meet, which means there is absolutely no solution. And then case 3, coincident lines. This is when both equations actually represent the exact same lines sitting right on top of each other. This means they touch everywhere, giving us infinitely many solutions.
Okay, moving to section 5, fractions and word problems. Yep, we've reached the boss levels.
We've mastered the basic tools, so now it is time to tackle those boss levels. First up, defeating fractions. Now, fractions can look totally intimidating, but the crucial first step is honestly just clearing them out of the way before you even deploy your standard tools. Let's look at step 1. We have x over 2 plus y over 3 equals 4. To remove those denominators of 2 and 3, we just find their common multiple, which is 6, and multiply the entire equation by 6. Suddenly, poof, the complex fraction transforms into a nice clean 3x plus 2y equals 24. From there, step 2 is just applying the elimination or substitution tools we've already learned, alongside our second equation, x minus y equals 1. And hey, don't panic if your final answers turn out to be fractions themselves, like 26 over 5. Just trust the process.
Next up, cracking a word problem. This really brings our whole detective metaphor full circle. Step 1 is always defining your variables. Let the first mystery number be x and the second be y. Step 2 is translating that English into math. The text says their sum is 20, their difference is 4. That perfectly translates to x plus y equals 20 and x minus y equals 4. So the really cool part is that once you translate the text, step 3 is just basic elimination. Add them together, 2x equals 24, so x is 12, and y is 8. And just like that, the mystery numbers are found.
Finally, let's head into section 6, exam tips and pitfalls. Let's open up the Pro Toolkit.
I want you to think of this as your essential survival guide for exams and tests. Knowing exactly which tool to pull from your kit will save you massive amounts of time when you're under pressure. So when do you use elimination? You want to choose this when the coefficients, the numbers right next to the letters, are already equal or really easy to make equal. And when do you use substitution? You choose substitution when a variable has a coefficient of exactly 1, meaning an x or a y is already sitting there all by itself, just waiting to be isolated and swapped up. And here are the common pitfalls you absolutely must avoid. Let's rapid fire through these. First, always perform the same operation on both sides of the equation. Watch out for sign errors because negative numbers trip up the best of us. Be precise with your substitution. Don't read your graphs inaccurately. Always use a ruler and a proper scale when you're drawing them. Always simplify your fractions. And the golden rule, never ever forget to check your final answers by substituting them back into both original equations. Seriously, if they work in both, you know with 100% certainty that you got the question right.
So as we wrap up this explainer, I want you to remember this. Simultaneous equations prove that even when things seem hopelessly unknown, a little structure and logic can reveal the truth. If every unknown in the world is really just a variable waiting for an equation, what mystery are you going to solve next? Thank you so much for exploring this with me, and keep bringing that awesome enthusiasm to your learning.